Hello guys, how are you? कैसे हैं बच्चे लोग? This is your KP sir on YouTube again. So myself Krishna Prakash. Students love to call me KP sir or EE sir. I have 16 years of teaching experience, trained more than 150 batches, and worked in all top coaching centers in India. Now in an academy online platform, I am going to teach environmental engineering, hydrology, irrigation, construction materials and open channel flow. So if you want to watch my free classes on an academy, you just search NVLK Prakash. You will get my free classes, watch the lectures, and if you want to join plus course, paid full length course of GATE and ESE, use the code KPCivil. Will get maximum discount and all the benefits provided for you. Use the code, don't forget what is the code? KPCivil. Use the code KPCivil, then take plus subscription. You will enjoy all the benefits. You will enjoy the full length GATE and ESE subjects. So before going to start the session, just a small announcement. In Unacademy, we are providing various free online tests. In that, this is an online competition. Most expected questions for GATE 2021. Very important. Most expected questions for GATE 2021. Free test series for any one of the student who is appearing for GATE aspirant. And along with providing free test series, we are giving you surprise gifts. Win the prizes worth 6 lakhs. You can win the prizes worth 6 lakhs. So 3 series of tests. 14th November test 1 already completed. 21st November test 2 on strength of material, structural analysis, RCC, steel and open channel flow. 28th November test 3 construction management, building material, fluid mechanics and transportation engineering. So what are the benefits you are getting? First of all, you get good subject knowledge. You are going to expose to subject oriented basic questions, very important questions, most repeated questions. So you are gaining knowledge. Anyway, while writing any online test series, you are gaining knowledge. Very importantly, it is a free test series. You are not paying anything for this test series. It is a free test series. And you will get rewards. For those who got first 1 to 5 ranks, will be rewarded with 2000 rupees. 6 to 10 ranks 1500, 11 to 25 ranks 1000. So like that, for each branch 3 topic wise test series conducted in 3 parts we have given here. Part test 1, test 2, test 3. You are going to getting benefited learning subject knowledge. Along with that, you are getting prizes rewarded for your benefit. Okay, enroll now for the test series as early as possible. And also ISRO Revise India syllabus. ISRO Revise India series as per the recent syllabus of ISRO. Free previous year question sessions and all India ISRO mock test for all branches, mechanical, electrical, civil, EC, CS and IT, for all branches. All India series ISRO mock test from 7th to 21st November. 7th to 21st November, free PYQ classes going on. Free PYQ classes going on in an academy. Then test is conducted on 22nd November. Again, win exciting prizes worth 3 lakhs. Enroll now itself. Enroll now itself. So, from an academy end, we are ready to support each and every student. Remember, not only for paid subscribed student, for each and every student who are unable to afford the prizes, we are providing free classes, we are providing free online test series, along with exciting rewarding prizes also. Everything we provide. The only thing from your end, you spend your time, write the exam, get rewarded with the exams. Okay, let's crack it. And one more announcement From 20th November, we are going to start Spark ESE 2021 prelims batch, 7 months batch, in which myself, Rajendra Prasad sir and Praveen Kulkarni sir will teach all civil engineering subjects, core civil engineering subjects. We will take care. So take your plus subscription as early as possible using the code KPCivil. Now coming to the today's session, 2016 GATE Civil Engineering, Engineering Hydrology. Only the questions from Engineering Hydrology 2016 GATE Civil Engineering. We are going to solve it. I promise to my students, I will provide you all previous year question solving sessions of environmental, hydrology, open channel flow, irrigation. So now we are coming ahead. This is 2016 already completed 17, 18, 19, 20 engineering hydrology. All 5 years environmental OCF completed. Now we are going ahead 2016 hydrology. Now the first question. The direct runoff hydrograph in response to 5 centimeter rainfall. Effective rainfall. Why I am taking this directly as effective rainfall? ERF. Directly I am considering ERF, effective rainfall, because 5 centimeter rainfall excess. The direct runoff hydrograph in response to a 5 centimeter rainfall excess. Rainfall excess is nothing but effective rainfall. Both are same. Rainfall excess is nothing but effective rainfall. Both are considered to be same. Is shown in the figure. Area of catchment required. Area of catchment required in given in hectares, expressed in hectares. So according to this is a triangular DRH, triangular direct runoff hydrograph. Peak, it is peak discharge. Peak discharge is given. Discharge, peak discharge of direct runoff hydrograph is given 1 meter cube per second. 1 meter cube per second. Then time is given 0 to 6 hours. Time base. I will take base time to achieve that 6 hours. So we'll conclude from this. Volume of effective rainfall. What is formula for volume of effective rainfall? Volume of effective rainfall is equal to, tell me what is the formula? Area of catchment. Area of catchment into depth of effective rainfall. Volume of effective rainfall is equal to area of catchment into depth of effective rainfall. The same thing we will express with other formula, because it is a triangular direct runoff hydrograph. It is a triangular direct runoff hydrograph. So it is the area of triangle half into base into height, because volume of effective rainfall is equal to area of direct runoff hydrograph, DRH, half into base into height. So now I am taking equalizing half into base. Base is a time base, H, height is peak discharge. Half into time base into peak discharge is equal to area of catchment into effective rainfall depth. I am going to equalize the volumes. Volume is obtained by two formula. First one is volume from area into depth. Second one is volume from area of triangle, direct runoff hydrograph. So half into time base into peak discharge is equal to area of catchment into effective rainfall depth. For any triangular direct runoff hydrograph, you can use the formula. If your hydrograph is unit hydrograph, in place of effective rainfall, it is the direct runoff, we are taking this. If your hydrograph is unit hydrograph, in place of effective rainfall, you take 1 centimeter depth, that is 10 power minus 2 meters. Same formula you can apply. For any triangular DRH and triangular UH, you can apply the same formula, half into TB into QPK, that is equal to area of catchment into effective rainfall depth. So from the given diagram, half into, what is time? 6 hours, time base 6 hours. Time base 6 hours. Peak discharge 1 meter cube per second. 1 into, I am converting second to hours. 60 into 60. 1 meter cube per second, I am converting 60 into 60 meter cube per hour. Half into 6 time base, 1 peak discharge in meter cube per second. 60 into 60 meter cube per second to convert to meter cube per hour. Area of catchment. This is what we need to determine, area of catchment. Effective rainfall depth 5 centimeters. I am converting to meter, 5 into 10 power minus 2. I am converting to meter, so we'll get 5 into 10 power minus 2. Area of catchment. What you are getting by solving this? By solving this, what you are getting? Area of catchment. 21.6 into 10 power 4 hectare. 21.6 into 10 power 4 meter square. 10 power 4 meter square is equal to hectare. So we can write it down 21.6 hectare. This is the answer now. Area of catchment is 21.6 hectare. I can write it down now. Any difficulty? If you know the formula, basic shortcut formula, half into time base into peak discharge is equal to area of catchment into effective rainfall depth. You can solve any of triangular unit hydrograph, triangular direct runoff hydrograph questions. Any model, easily you can solve it. Simple. We'll go ahead now. Finished. First question, 2 marks, you got it. You got it, 2 marks. Okay. The ordinates of 1 hour unit hydrograph at a 60-minute time interval. Ordinate of 1 hour unit hydrograph at a 60-minute time interval. So I am taking time and 1 hour UH ordinate. Time and 1 hour UH ordinate. 1 hour UH. 1 hour UH. A 2 hours term of 4 centimeter. 2 hours term of 4 centimeter excess rainfall occurred in the basin from 10 a.m. In the basin from 10 a.m. So rainfall occurred, you remember, rainfall occurred is 2 hours. Rainfall occurred is 2 hours. Rainfall duration I am writing. Storm duration, rainfall duration I am writing. Storm duration 2 hours. What is your unit hydrograph provided? Unit hydrograph provided is 1 hour. Means what is the target? You need to convert this 1 hour unit hydrograph to 2 hour unit hydrograph. Storm duration is 1 hour, 2 hour. Unit hydrograph data clearly mentioned 1 hour unit hydrograph. 1 hour unit hydrograph. You need to convert 1 hour UH to 2 hour. Rain is started at 10 a.m. Rain is started at 10 a.m. So for that, what I am doing, I will convert this 2 hour storm, 0 to 2 hour storm. I will convert this 0 to 2 hour storm into, I will convert this 0 to 2 hour storm into 2 storms. 0 to 1 hour storm, 1 to 2 hour storm. 2 rainfalls. Rainfall 1 for 1 hour. Rainfall 2 for 1 hour. So when rainfall 1 started? Rainfall 1 started at 10 a.m. resulted discharge at 11 a.m. Clearly mentioned. Rainfall 1 started at 10 a.m. resulted discharge at 11 a.m. When rainfall 2 started? Rainfall 2 started at 11 a.m. resulted discharge at 12 a.m. Discharge values are same because you are taking for unit depth 1 centimeter depth. Unit depth. Rainfalls happened are for unit depth you are taking. Rainfall 1 10 a.m. to 11 a.m. Rainfall 2 11 a.m. to 12. 11 a.m. to 12 noon. 11 a.m. to 12 noon you are taking. So what happened in such a case? Each 1 centimeter rainfall, each 1 hour duration, representing same ordinates, representing same unit hydrograph ordinates. So first I will write down the time wise unit hydrograph ordinates. Time 10 a.m., 11 a.m., 12 noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m. This is time. Given data is 1 hour unit hydrograph data. Shall I take it directly for storm 1? Storm 1 started at 10 a.m. I am taking 10 as 0. Shall I take it directly for storm 1 data? That is, yes, I can take 0, 3, 12. This is data for rainfall 1. I am considering data for rainfall 1. 0, 12, sorry, 0, 3. Ordinates I am copying here from the given data. From here I am copying the ordinates. 0, 3, 12, 8, 6, 3. 0, 3, 12, then 8, 6, 3. 863 0. So these are 1 hour unit hydrograph ordinates for rainfall 1. Now I am writing rainfall 2 1 hour unit hydrograph ordinate delayed. When rainfall 2 started, tell me? Delayed by 1 hour. Delayed by 1 hour. It is started at 11. So it does not carry value at 11. It is started at 11. It does not carry value at 11. Same values I am taking here. 3, 12, 8, 6, 3, 0. Same values I am taking but delayed by 1 hour. Because it is started at 11. Executed discharge at 3. What is our question? Considering constant base flow of 20, constant base flow of 20, flow of the river at 1 p.m. we need flood discharge at 1. We need flood discharge at 1 p.m. At 1 p.m. we need flood discharge. Now you have the ordinates of for rainfall 1 and ordinates for rainfall 2. Combined is 2 over DRH. Combined is 2 over DRH only, na? Because 1 over UH for rainfall 1, 1 over UH for rainfall 2, we are adding both. It is 2 centimeter now. It is not 1 centimeter. 1 centimeter for rainfall 1, 1 centimeter for rainfall 2. 2 centimeter now. So it is not unit hydrograph. It is a direct runoff hydrograph. As depth of effective rainfall is 2 centimeter. So we can take the values now 0, 3, 15, 20, 14, 9, 3, 0. 0, 3, 15, 20, 14, 9, 3, 0. 2 hour direct runoff hydrograph. From this, I can write down 2 hour unit hydrograph ordinates. 2 hour unit hydrograph ordinate is equal to DRH ordinate into D by T. What is D by T? Total duration is 2 hours. D is 1. D is equal to 1 because unit hydrograph is given for 1 hour. Total duration of rainfall is for 2 hours. What is D by T? 1 by 2. D by T is 1 by 2. Now I can take it now. 0, 3 by 2, 15 by 2, 20 by 2, 14 by 2, 9 by 2, 3 by 2. So just it is into 1 by 2 is nothing but making half. Why I am taking 2? Your unit hydrograph provided is 1 hour. Your rainfall happened is 2 hour. So converting 1 hour to 2 hour. D is equal to 1, T is equal to 2, 1 by 2. So we got the answer now. Here 1.5, 7.5, 10, this is 14 by 2, 7, 4.5, 1.5. So you need at 1. The question is flood discharge at 1. What is unit hydrograph discharge at 1? 10. You understand? At 1 p.m. unit hydrograph discharge is 10 meter cube per second. At 1 p.m. unit hydrograph discharge is 10 meter cube per second. Then what is flood hydrograph? Now direct runoff hydrograph discharge at 1 p.m. into effective rainfall. What is effective rainfall depth? Clearly mentioned. Effective rainfall depth is 4 centimeter. So DRH is equal to UH into 4, 40. And what is flood hydrograph? Flood hydrograph is equal to direct runoff hydrograph plus base flow. Base flow. I have given all the formula. I think you remembered. QDRH is equal to, I am writing again. QDRH is equal to QUH into effective rainfall depth. QUH into effective rainfall depth. At 1 p.m. What is QUH? QUH is determined. At 1 p.m. it is 10. So 10 into effective rainfall depth 4 centimeter. So 40 meter cube per second. 40 meter cube per second. Q flood hydrograph. QFH is equal to QDRH plus. Tell me QDRH plus base flow. QFH, Q flood is equal to DRH plus base flow. How can we write down? 40 plus, what is base flow? Base flow given, na? Base flow given, na? 20. Base flow is 20. 20 meter cube per second. 60 meter cube per second. Q flood is equal to 60 meter cube per second. QUH 10, QDRH 40, 40 plus 20, 60 meter cube per second flood hydrograph. Your final answer you can write down here as 60. Your final answer you can write down here as a 60. Got it? Clear for everyone? You got the answer? Now, the type of flood routing and the equations used for the purpose are given below. The type of matches. So, easy question, hydrologic flood routing, hydraulic flood routing. Equations obeying for it. Hydrologic flood routing, hydraulic flood routing, equations obeying for it. Hydrologic flood routing will obey always continuity equation. So, P is equal to 1. Hydrologic flood routing always obey continuity equation, P is equal to 1. Hydraulic flood routing obeys continuity equation as well as momentum equation. Q is 1 and 2. It obeys both continuity equation as well as momentum equation. So, P1, Q1 and 2. P1, Q1 and 2. What is the answer? Answer is B. Answer is B. P1 and Q1 and 2. Answer is B. That is the answer. We'll go to the next question.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of Civil Engineering in India, KPCivil on an academy. I am a big fan of his teachings.
Oh yes, I have also heard about KPCivil. I am willing to join the class.
It's nice. Take subscription in an academy using KPCivil code. You will be benefited more. Okay, let's crack it.
A tracer takes 100 days. A tracer takes 100 days to travel from well 1 to well 2, which are 100 meters apart. Consider this is well 1 and this is well 2. An inert tracer is loaded. In between well 1 and well 2, you have loaded an inert tracer. The distance between well 1 and well 2 is 100 meters. This is well 1 and this is well 2. The distance between well 1 and well 2 is 100 meters. Elevation of water surface in well 2 is 3 meters below that in well 1. So consider this is elevation of water surface in well 1 and this is elevation of water surface in well 2. So the tracer is traveling like this. Tracer is traveling like this. So distance here is 100 meters. What is the height difference? DH head. What is head here? 3 meter head. 3 meter head. Water surface elevations are provided 3 meter head. Assuming porosity equal to 15%, 0.15. The coefficient of permeability, K value is how much? K value is how much? So you need the value of K, coefficient of permeability. You take continuity equation with respect to velocity. Velocity, continuity equation, velocity is equal to K into I. K into I. From this, what we can write down? Coefficient of permeability, K is equal to velocity by hydraulic gradient, I gradient. Now, velocity is equal to, we will consider velocity is equal to, tell me what is velocity? Velocity is equal to VA into N. VA into N. Now we'll calculate VA. VA is equal to distance by time. Length of travel by time taken. 100 meters is length of travel. 100 meters is length of travel. Time taken to complete 100 days. Na? Time taken to complete 100 days. Na? 100 days. So we'll take VA is equal to 1 meter per day. VA is equal to 1 meter per day. V is equal to 1 into porosity is 0.15. 0.15 meter per day. V is equal to 0.15 meter per day. Any difficulty here? Given is actual velocity V, distance by time, 1 meter per day. You need apparent velocity V, VA into N, 1 into 0.15, 0.15 meter per day. Then, what is I? I is equal to DH by L, head by distance. Head is 3 meter, distance is 100 meter. So we can take it 0.03. Finally we'll derive K value. K is equal to 0.15 by 0.03. 0.15 by 0.03 we are getting K value 5 meter per day. We got V first. By taking V is equal to VA into N. VA determined length by time, distance by time, velocity 1 meter per day. With respect to porosity, when compared with porosity, it is reduced 0.15, 1 meter to 1.15 meter per day. Gradient is equal to head by distance, head by length, 3 by 100, 0.03. Substituted in the K formula, 0.15 by 0.03, 5 meter per day, you got it. This is the answer. Option D. Option D we can go ahead now. Option D we can go ahead now. Now, again from well hydraulics only. Water table of an aquifer. Water table of an aquifer. Declined or drops by 100 centimeter. Means change in groundwater table depth. Change in depth of groundwater table 1 meter. 100 centimeter I am taking 1 meter. 100 centimeter we can take now 1 meter. Over an area of 1000 kilometer square. Over an area of 1000 kilometer square. Area 1000 kilometer square. The porosity and the specific retention of the aquifer material. Porosity 25% N, specific retention SR 5%. N is equal to 0.25, specific retention SR is equal to 0.05. If porosity is specific retention given to you, what you are getting, tell me? If porosity and specific retention is given to you, you will get a specific yield. No? Specific yield is equal to specific porosity minus specific retention 0.25 minus 0.05. You will get specific yield 0. Simple, no? Specific yield is equal to porosity minus specific retention 0.25 minus 0.05. Specific yield 0.5. Now, what is required? Amount of water drained out in kilometer cube. Volume. Kilometer cube means volume only, na? Volume of water drained out. We'll consider change in groundwater volume. This is nothing but delta GWV. Change in groundwater volume, delta GWV. V means volume, is equal to area into depth, change in depth, groundwater table depth into specific yield. Area into change in groundwater table depth into specific yield we can take. We'll substitute the area 1000 kilometer square. 1 meter groundwater table depth I will convert to kilometer because we need the answer in cubic kilometer, expressed in cubic kilometer, clearly mentioned. We need the answer in cubic kilometer, expressed in kilometer cube. 1000 into 1 into 10 power minus 3. This is in kilometer square. This is in kilometer, we'll get cubic kilometer. Specific yield 0.05. Now what is the answer? 1000 into 1 into 10 power minus 3 into 0.051. What is the answer you are getting? Tell me. Wait. What is specific yield? What is specific yield? Specific yield 0.2 na. So you take here 0.2. So you will get a 0.2 kilometer cube. Answer is 0.2. Answer is 0.2 kilometer cube. Simple question. One formula you know, you solve the question. Change in groundwater volume is equal to area into change in groundwater table depth into specific yield. Change in groundwater volume 0.2 cubic kilometer. Finish. So these are the 4 questions. 2 questions from hydrograph, 2 questions from well hydraulics given in 2016 GATE exam. So take full length course of GATE and ESE from an academy using the code KPCivil. I am going to teach environmental engineering 140 hours, engineering hydrology 60 hours, irrigation engineering 60 hours, open channel flow 60 hours, building materials and construction management 60 hours. No coaching center, no teacher will taught this many number of hours, this much content, depth, subject knowledge. You understand that many hours why I am spending? To give a single step solution for all your exam needs. You are writing GATE, you are writing ESE, you are writing UPPSC, APPSC, state government exams, SSC, JE, ISRO, BARC. For every exam pattern is different, you are taking different coaching. Instead of that, one step solution for all kinds of your needs. That one step solution for all your needs, take your plus subscription using my code KPCivil. Easily you will get top rank in GATE and ESE. I will guide you. I am with you till you crack GATE examination. And every Thursday we are conducting free online test series Super 30 for any student. In Unacademy app, you check my profile KPCivil, you search. Every Thursday you can write 30 questions, 1.5 hour examination. GATE standard, very typical questions, which is a free online test series for every student. So remember, every Thursday 5 PM you check my profile in Unacademy, you are having online test series. Okay. It is free for every student. You can write, anyone can write. You may take subscription, may not take subscription. For every student it is free. Hope you enjoyed the session. Don't forget about the code. Code is KPCivil. Okay. Thank you one and all the best.